how mountains are made. Look at that. There are mountains all around us. We live in a little town in a valley. On Saturdays, sometimes we go mountain climbing. We follow a trail through a thick forest. At first, the climb is easy. Then it gets steeper and steeper. We stop on a rock ledge halfway up and eat our lunch. When we start out again, we have to walk more slowly. The slope is getting very steep. The forest is thinning out, and the trees are shorter. We can see the top of the mountains, but it seems to take forever to get there. Are we there yet? When we reach the top, we can see out in every direction. There are hardly any trees up there, and the land is rocky. We spend a long time looking at rocks. Here is one with the shape of a seashell in it. Cool, it's a fossil. Fossils are the remains of animals that lived millions of years ago. This mountain is more than 4,000 feet high. That's nearly a mile. There are no oceans up here. How did the sea animals get to the top of the mountain? The highest mountain in the world is Mount Everest in Nepal. It is 29,028 feet. That's almost 5.5 miles. But fossil seashells have been found on Mount Everest too. Mount Everest would be about this high compared with our mountains. The deep sea plains are between 2 and 3 miles below sea level. Our mountain is less than 1 mile above sea level. Here is sea level. See that line? Millions of years ago, Mount Everest was not a mountain at all. It was flat plain under the ocean. Our mountain was a flat plain under the ocean too. All sorts of sea animals lived here. But that was a long, long time ago. Many changes have happened since then. Look at all those sea animals. Does any of them look like that fossil? The earth is always changing. Old mountains disappear. They are worn away by wind and ice and rain. New mountains form where there were no mountains before. We can't see these changes happening, though. Mountains are built up and worn down gradually over hundreds of millions of years. When we look at the earth, all we see are rocks and soil, and the trees and other plants growing in the soil. But if we could look inside the earth, we would see that it is made up of different layers. The surface of the earth is the first layer. It is made of the soil and the rocks we see all around us all the time. Just under the surface is a rocky layer, about 35 miles thick, called the Earth's crust. Beneath the crust is a layer of solid rock about 60 miles thick. The crust and this thick rock layer together form an outer shell called the lithosphere. Look at, this is the top, and this is way under the dirt. If you dig down, that's what the earth is made out of. That's what it looks like. And there's a layer of crust, and then there's solid rock. It goes deeper, and all of this is the lithosphere. The lithosphere is broken into pieces called plates. The plates are huge. There are 8 major plates and several smaller ones. The United States, Canada, and Mexico are together on one of these plates. Europe and Asia make up another plate. See those plates? Under the outer shell is a layer of hot, partly melted rock called magma. The rock plates float on top of the hot magma. The plates move slowly over the magma just a few inches a year. The Earth's plates are always in motion. They have been moving for hundreds of millions of years. Most scientists believe that all mountains on the Earth are formed by slow movements in the Earth's outer shell. But mountains in different parts of the world look different from one another. These are folded mountains. They have sharp, pointy peaks. And these are dome mountains that are rounded. These are fault block, and they are shaped like blocks. And this looks like a volcano because it's a volcanic mountain. It looks like a tall cone. They're all different, and that's because different parts of the the outer shell moves in different ways. In some places, 2 plates press against each other. The tremendous pressure forces the crust to lift and fold over itself. Great waves of rock are pushed. Sharp, craggy mountains are formed. These are the folded mountains. And if you have a dish towel, you guys can get on each side of the dish towel and push it together while laying it flat on the ground and see how it folds up on itself. So you can see what folded mountains, how that works. Here you go. Lay a towel flat on a table. Put the palms of your hands down on each end of the towel. Then slowly slide your hands towards each other. Scrunch. The folds and ridges that appear in the middle of the towel are like the folds and ridges that form in the giant mountains when 2 plates press against each other. In other places, pressure deep within the earth pulls and stretches the crust. The stretching sometimes causes the cracks in the fault lines to cut through the crust. See the magma pressing up against the surface, and it stretches the grass and the land. Here we go. This is a fault block. It almost looks like blocks, right? The crust on one side of the crack may slide slowly upward, while the crust on the other side pushes down. Block-shaped mountains are formed this way. Sometimes the crust does not fold or crack. Sometimes magma pushes through a vent in the solid rock layer. It collects in a pocket under the crust. The pocket of magma grows larger until it bends the crust upward. When this happens, a high dome is formed. Wind and rain and ice wash away the softer rocks above, and rounded peaks and valleys appear. These are the dome mountains. In a few places on Earth, plates are moving away from one another. This usually happens deep under the ocean. Ocean, the plates, and they're moving apart. Underground mountain ranges. Magma pushes up through the spaces between the plates. When it hits the cool water, the magma becomes solid. Great underwater mountain ranges are built up. Once in a while, a small crack or event forms in the lithosphere, sometimes right in the middle of the plate. Red-hot magma pushes up through the crack. When it gets to the surface of the Earth, the magma cools and hardens. Once magma reaches the surface, it's called lava. Lava and ash build up around the crack, making the land higher and higher. Cone-shaped volcanic mountain is formed. Most volcanic mountains are formed in places where one plate pushes against one another, under another. As the edge of the plate sinks, pressure and friction cause it to heat up. The solid rock of the plate's edge melts in the intense heat. The melted rock or magma pushes up through the weak places in the crust above. This is the volcanic mountains. In a fiery blast, magma is thrown onto the Earth's surface. It cools and hardens, and mountains are built. Some mountains have been around for hundreds of millions of years. Others are still being built up right now. The mountain we climbed is an old mountain. The fossil we found can tell us a lot about how old our mountain is. Scientists have a special way of telling at the age of a fossil. This one is nearly 280 million years old. That means that the sea animal was actually swimming here 280 million years ago. It died, sank to the bottom, and was buried in the sand and the mud. It must have been buried sometime just before our mountain began to be born. So we know that the land here began to rise around 280 million years ago. From the shape of this mountain, we can tell it was formed by a folding of the crust. Two huge plates slowly pressed against each other. The land rose higher and the sea disappeared. Over millions of years, the crust folded up in tremendous waves. The mountain and the other mountains around our town were once much higher than they are now. They were sharp and craggy. Now they're lower and smoother. For millions of years, rain, wind, and ice have worn our mountains down. Millions of years from now, the wind, the rain, and the ice will have worn them down completely. But millions of years ago, now, millions of years from now, there will be no mountains. Mount Everest is a younger mountain. It is still sharp and craggy, and it is still being pushed up higher. Mount Everest may be growing as much as 2 inches each year. We're not going to try to climb Mount Everest. This mountain was high enough for us. Hope you guys had a good time listening to the books, and I'll try to make some more books for you another time.